We'll be talking about finding the domain and the range of a function or a relation. Let's see what the ideas are that we need to keep in mind. First of all, the domain, what is it? Well, the domain describes all the possible inputs to a function or a relation, while the range describes all the possible outputs from that function or relation. We have different ways that we can represent domains and ranges, and we'll be looking at a couple of ways. We'll be looking at set notation and interval notation. Let's take a simple example just to get the hang of what domain and range mean, and then we'll talk about the various notations that we can use. Looking at the table on the left, we want to figure out what the domain is. Remember that the domain is a set of all possible inputs. When we have data in a table like this, the left-handmost column we generally take to be the inputs. So our domain consists of the different days, day 1, day 2, day 3, day 4. And our range consists of the outputs, 95, 98, 99, and 95. So all the temperatures. This is an example of set notation. My domain is the values 1, 2, 3, 4. And my range is the values 95, 98, and 99. And now notice that even though the value 95 occurs twice in my table, I only write it once. I don't write duplicates. Let's look at the second table. All I've done there is just reversed my inputs and outputs. So now my inputs are the high temperatures and the outputs are the days. So my domain consists of all the high temperatures, again not writing any duplicates, and the range consists of all the days. This is set notation, and in this particular set notation, we've listed each individual value. And when there aren't many values, this is easy to do. However, sometimes it's not practical to list every value because there are just too many. For example, what if you had a domain where x could be any real number and x was greater than 0? So translating that, what we're saying is that x is any value that's a real number and that's greater than 0. Well, that's a whole heck of a lot of numbers. So when it's not practical to list all the values, then we describe the values. So domain, we're looking at in set notation all x such that x is a real number and x is greater than 0. Let's translate that into interval notation, which is the second kind of notation that we'll talk about. And it's actually very commonly used. Here's what it looks like. D, that stands for the domain, is equal to, and now we have two values. We have our starting value, our lowest value, and we have our highest value. So our domain starts at 0 and it ends at infinity. Well, of course, we know infinity never ends. But that representation is called interval format. We have a starting point and an ending point. The starting point is always the smallest number, the ending point is always the largest number. Now we don't always use parentheses. We use parentheses to indicate when the endpoint is not included. So in this particular example, we had specified that x had to be greater than 0, but it could not equal 0. So an open parenthesis indicates that that 0 is not actually included and that our domain starts just a hair bigger than 0. At the other end, our endpoint is infinity, and by convention we always use an open parenthesis when we're talking about infinity. Now, what if our endpoint is included? Well, in that case, we would use a square bracket instead of a parenthesis. Let's look at some examples. Here's a domain where we go from -5 to 3. We're using parentheses, so what we're really saying is all real numbers between -5 and 3, but not including the -5 or 3. Remember, we're talking real numbers, not just whole numbers. So fractions, decimals, anything like that is included. Here's an example where we have a square bracket. This translates to all real numbers between -5 and 3, including the -5, but not including the 3. So you start right on -5 and you go right up to, but not quite touching, 3. An example with a square bracket at the ending point. So we're looking at all real numbers between -5 and 3, but not including the -5. And finally, using square brackets at both ends, we're saying all real numbers between -5 and 3, including both the 3 and the -5. Let's see how we can pick out a domain and range when what we've got in front of us is the graph of a function. Recall that the domain is the set of all possible inputs, and on a graph, that really translates to the set of all x values. And the range represents the set of all y values. So finding the domain means asking, what are all the possible values for x that will be x coordinates on the points of our graph? So if you look at the graph itself, what are all the possible x coordinates we could have? Well, you can see that this graph is going to extend to the left and to the right into infinity. Those arrows at the top of the graph are slightly angled out, so we're going to continue to get smaller and smaller and smaller x coordinates and larger and larger and larger x coordinates. So in this particular case, our domain is going to consist of really all real numbers, so from -infinity to infinity. Now finding the range means asking what are all the possible values for y that will be y coordinates of our graph. Now we've got a limitation. You can see that right at the point 0, 1 is where our graph turns around. So there are not going to be any y coordinates that are smaller than 1 because the graph just doesn't dip down any farther than 1. So our range goes from 1, and we include the 1, so we show that with a square bracket, up to infinity because our graph extends forever in the upward direction. Let's look at another example. Again, we look at the domain. What are all the possible x coordinates that we could have? Well, we're going to extend to the left and to the right infinitely, so our domain is going to be all real numbers. And our range, well, our graph extends up and down forever. So our range is also going to be all real numbers. Let's look at this example. You can see when we look at the x values, so focusing in on the domain, that for our x coordinates, we don't have any x coordinates which are going to be below 0. So that means that our domain consists of all the x values that start at 0 and include 0 and continue up forever to infinity. In terms of our range, we've really got the same situation. Our graph doesn't go below 0 in terms of the y values. So our range goes from 0 to infinity. So we've looked at finding the domain and the range from a table of data, and we looked at finding the domain and range from a graph, and we expressed the domain and range in interval notation. Let's see if we can pick out what the domain and range are when all we're given is the function itself. What we're asking ourselves, for what values of x is our function defined? So looking at the first example, f of x is equal to 2x plus 5, are there any values for x that you could put in there that you would not be able to calculate an output for? Well, no, you could put in anything you wanted and you'd be able to calculate an output. And what would come out? Are there any limitations? Would you get anything and everything? Well, you definitely would. So our domain is going to be all real numbers, and what this function spits out, our range, is all real numbers. And let's look at that in interval format. Next example, f of x is equal to x squared. Again, we ask ourselves, is there anything that we couldn't put in there? Is there anything that's not allowed or that would make that function blow up? No, in fact, any number that you want, you could put in there for x and you'd be able to calculate something. So we've got all real numbers for our domain. And now what about the range? Think about this for a minute. If you put in any positive number for x and you square it, you're going to get a positive value out for the function value or the y value. What happens if you put in a negative number for x? When you square a negative number, you're also going to get a positive number. So what we see is that we're never going to be able to calculate a negative number as an output. So our range is limited to all real numbers that are greater than or equal to 0. Third example, f of x is equal to the square root of x. Is there anything we could put in there for x that would make that blow up? Well, indeed, yes. If we put in a negative number for x, we won't be able to calculate it. That will be an imaginary number. And for domains and ranges, we're just looking at real numbers. So 0 is going to be the smallest number that we can put in there, but we can extend all the way to infinity. And now the range is going to be similar, because if we've got a positive value in there as an input, all we're going to get out of there is a positive value. So for both the domain and range, we have all real numbers greater than or equal to 0. And finally, the last one is similar. We've just shifted it a little bit. We know that we can't end up with a negative number under our radical, so we ask ourselves, what value of x do we have to plug in there to make that negative? Well, it turns out if you put in any number less than 1, you're going to end up with a negative under your radical, and that's not acceptable. So in this case, we've got a domain that's all real numbers greater than or equal to 1, and our range is going to be all real numbers that are greater than or equal to 0.